Okay, we're going to be taking a look at how electrons behave within atoms. In this chapter, we're taking a look at addresses and where each and every electron is. So if we think about it in terms of just assigning an address, this chapter becomes a lot easier. The first thing that we're going to be looking at with this chapter is the quantum theory. And I can't emphasize enough that we're explaining where electrons are located. First thing that we're going to be taking a look at is a quantum level, which is simply rows, where we find each and every electron, and they exist in different energy levels, starting closest to the nucleus and working their way out. The outer electrons, or outer levels, are more reactive than inner, so really the outer ones are the ones that are responsible for chemistry and chemical reactions. We're going to be explaining these electrons in several ways. The first way in this tutorial is an electron configuration. Subsequent tutorials are going to be working on orbital diagrams and quantum numbers. And then lastly, we're going to finish up with Lewis dot diagrams. So if we look at quantum numbers themselves, we have to describe them in several ways. The first way is in a principal quantum number. We use the value of n to represent that. And don't get scared by these letters. It's just a way of saying the n value is what row it belongs to. On our periodic table, we would have rows 1 through 7. The second way that we describe electrons is what sublevel they belong to, S, P, D, or F. And on the periodic table, we labeled those, and I'll be labeling them shortly. The third value is a quantum of the orbital. We use an M to represent that value, and we'll see that when we do orbital diagrams, what an orbital value would be. Orbitals are simply pairs of electrons. So S has 2 columns, that's 1 pair. P has 6 columns, so that's 3 orbitals. D has 10, which means 5 orbitals, and F has 14 columns, which would equate to 7 orbitals. The spin just simply means, is this electron spinning clockwise or counterclockwise? Now, here's what we did for labeling the periodic table. First thing that we did is we labeled the principal quantum numbers. So it's just simply labeling the rows. The next thing that we did is we labeled the sublevels. Columns 1 and 2 are S. Now for this, keep in mind, helium needs to belong here in column 2. We won't worry about it belonging over here. It belongs over there for a different reason. So S is in the first column, first 2 columns. The P value is columns 13 through 18, so we labeled that P. Now the D block are our transition metals, columns 3 through 12, and D, and we labeled that with a -1. The reason for that is, even though in energy level 4 we have the S sublevels, this would be the beginning with scandium. This would be the beginning of the 3D. There's an overlap of these energy levels, so 4S actually is closer to the nucleus and fills first, then the 3D sublevel. So it goes 4S, then 3D. Then lastly, there's the F sublevel, and that's a -2. So those guys, the lanthanoids and actinoids, they belong up here. Energy level 6 fills first, 6S fills first, and then 4F. That's why we have a -2 behind the F. After the F series fills, then element 71 and element 103, those are the beginning of the D. So keep in mind that those are -1, and that's what gets students all the time is seeing that value and forgetting that that's a D. So we have S, P, D, and F blocks. Now, if we look at this, and I'll go back to the periodic table so you can see that, here are some questions that you can answer. We answered these in class. Energy level 1, if you go back to the periodic table, we see energy level 1 is the first row. If I look in this row, all I see are the S blocks, elements 1 and 2, and nothing else. Okay, so there's only one orbital or one sublevel found in energy level 1. Energy level 2 has S's as well as P's, so there are 2 sublevels that we would find, S and P. Energy level 3 we have to be careful with. We have S, we have P, but we also have all of these D's. They just happen to be found after the 4S sublevel fills. So energy level 3 has 3 sublevels. Electrons then, if we look at electrons and go back to the periodic table, you can see this. Energy level 2 has S as well as P. S has 2 electrons that it can hold. P has 6. So you add those two up. 2 plus 6 is 8. Energy level 2 can hold 8 total electrons. We'll be answering this last question with orbitals in the energy level 3. We'll be answering that with orbital diagrams. But if you think energy level 3 has S, P, and D, there's 1 orbital in S, there's 3 in P, and there's 5 in D. So we're talking pairs of electrons in orbitals. So 5 plus 3 is 8, plus S would be 9 total orbitals. Now, an electron configuration includes the energy level, N, the sublevels, S, and it can infer the number of number of orbitals, the M. So we'll take a look at that, and let's do a couple of examples of how to write an electron configuration. Let's start with aluminum. Okay, aluminum is element number 13. So again, we have energy level 1, energy level 2, energy level 3. We always start when writing an electron configuration with energy level 1. The sublevel I see is S, and there are 2 electrons there, columns 1 and 2. That's it. That's all the orbitals and all the sublevels that we find there. Then we move to energy level 2. Energy level 2, the first sublevel we run across is S, and we have 2 electrons there. We follow straight across, and we can see that there's also a 2p sublevel. And we count 1, 2, 3, 4, 5, 6 total electrons there. I'm not to the element aluminum yet, so I keep on moving forward on the periodic table. I get to energy level 3. Energy level 3 has an S, has 2 of those, and I move over to element 13. That lives in, this is the 3p1 sublevel. Okay, so that's aluminum. Now let's take a look at a little bit more complex one, and we'll pick something, let's say, let's pick platinum. Okay, so we start again at the beginning, energy level 1, sublevel S, there are 2 electrons. Energy level 2, sublevel S, 2 electrons. Energy level 2, sublevel P, 6 electrons. Energy level 3, S, 2, 3, P, 6. I move on to energy level 4, sublevel S, and now I've got 2 of those. Here's energy level 4 here. I'm to calcium. Now remember, getting into scandium, we have to remember this is a D block, so we subtract 1 from the energy level. That is energy level 3. That's the D block, and there are 10 columns there. There are 10 electrons that fit in. That brings us up to gallium, which is energy level 4, sublevel P, 6. I move to energy level 5, sublevel S, 4, D, 10, 5, P, 6. Now I'm down to energy level 6 with cesium. Energy level 6, sublevel S, and I've got 2 of them. Then I hit the star. On your periodic tables, lanthanum lives there. Remember, that's the beginning of the F series, and we subtract 2 from the energy level, so that's a 4F. There are 14 electrons adding up to ytterbium, element 70. Starting with lutetium, keep in mind that's a D, so we subtract just 1 from the row number of 6. Lutetium is the D block, and we count lutetium and hafnium, 2, 3, 4, 5, 6, 7, and 8 for platinum.